Daima is asking, is there any plans on having so avatars and other assets load up on the background from a buffer rather than all at once? Simulator at however handles the avatar loader. They actually load in the background. So there's one of these kind of like misconceptions that is like around. Like whenever you load assets, all of that loading, it actually happens, on background threads. All the fetching, like what essentially happens is the data model, it makes a request. It's like, I want this asset. And then, asset system takes over, and all the downloading, all the loading of the asset, it happens in background threads. And then it sends the data to be loaded to the GPU that does need to be synchronized to the main thread. For textures right now that will do time slicing, and it's it's a limitation of the DirectX 11 API because it doesn't support uploading from a background thread. It needs to be done from a main thread, unfortunately. But majority of it is already happening on background threads. There's one of the issues because we are doing the loading ourselves. Because the loading is actually heavily multi-threaded, it tends to allocate a lot of memory because it tries to utilize your CPU cores, but it actually triggers the garbage collector in Unity, which causes some of the freezes, and it kind of hurts because the garbage collector, it has to pause the entire application. And it's one of the reasons, why we want to move to .NET 9, because it has way better garbage collector. The background threads will not impact the foreground thread as much as, as can happen. With stuff like VRShell, because they are using, at least I'm pretty sure they're using Unity's functionality. Unity is running that outside of C# in their own code, so that, doesn't trigger that. But because we are pretty much an engine, our own engine, within a game engine, we kind of hit the limitations of the runtime. And that's, why I kind of want to move it out of there. One thing that's going to help a little bit is time slicing of the mesh uploads. Because right now that doesn't happen. So the meshes specifically, they get loaded at once. And that was a little bit trickier as well because Unity doesn't provide good APIs for doing that. It doesn't provide it even for textures. We kind of had to design a system that's just kind of hooks into Unity, and we essentially implement our own texture uploading to the GPU, which is a fair bit of work, but it kind of helps, so you don't freeze up as much. And kind of needs to do similar thing for meshes, but there's a little bit more trickier there. It might happen as part of the split because I might need to change, how the data actually gets transferred over. But for the most part, it already does happen on background threads. And some of the kind of freezes you're feeling, it's actually coming from other parts, the runtime. The runtime kind of not actually handling the parallelization as much, which is also a reason, why we tell people, we oftentimes, notice people have this association that just make everything multi-threaded. It's gonna make everything better. It's gonna make everything faster, and people think of it as a silver bullet that's gonna solve all the performance problems. But it's really not. In some cases, actually might end up being detrimental because if you have limitations of the runtime. Once we switch to .NET 9, it actually makes it way better because the runtime is kind of designed for that a lot better to handle all those background threads, because with .NET 9, all the background threads, they also get their own chunk of memory to work with, so they don't even need to block other threads, versus with the Unity one, there's just one shared one. So if one thread does a lot of memory allocations, that's gonna make the garbage collector stop all of the threads, in every single case.
Yeah, the .NET garbage collector is meant to work
on servers.
It's concurrent, isn't it?
Yes.
Yeah.
It's concurrent, it's compacting, it's doing a lot of things. It's generational, that's the important thing. Because there's actually, if I grab a brush, I don't know if this is going to be too small. It's going to be just a little sketch, but say this is your, this is your memory. And, and you'll allocate, something here, and something here, something here. And then, it decides, okay, I'm going to free up some memory. And say, this is, say 16 gigs of memory allocated. That's quite a bit, but let's imagine it's 16 gigs. Um, and the garbage collector is like, I need to... Oh, what happened to my controller? Oh, there we go. It needs to free some memory. It has to scan everything. Even like if this is fixed, this is fixed, this is fixed, this is fixed, and maybe this is fixed, it scans all the 16 gigabytes pretty much to figure out, okay, there's a little bit space here and there's a little bit space here to free up. What like the modern generational garbage collectors do, they actually have like tiny bit of memory. It's usually something like 4 gigabytes, where all the new allocations happen, or at least most of them. Then there's like bigger chunk of memory where there's like more long-lived allocations, and there's like another one for really big things. So if something really big, it goes here. Most allocations will go here. And there's like interesting thing, but like the way most applications are written, most allocations are very temporary. So whenever it needs to free up more memory, it actually just looks at this tiny piece of memory. It frees that up. Anything that it cannot free, it's gonna move over here to like more long-term memory. And now instead of scanning, 16 gigabytes, it's scanned 4 megabytes, which is, orders of magnitude faster. And it only cleans like this one, every now and then. And then anything that's like really big, it puts it into special blocks so it can handle it even more efficiently. So like this table is gonna have like, smaller bits, and then very large allocations are gonna go into their separate piece. And that helps a lot for the garbage collector to just have like way better performance, because it can free up like, this tiny chunk of memory most of the time. It doesn't need to collect this one as much. It's also gonna, it's gonna, like, whenever it's dying to free, it can actually kind of do that without stopping the application. The garbage collector is in Unity, it needs to, like, the moment it starts trying to scan the memory, it essentially stops everything. It pauses your process to do scanning. And it kind of, like, to prevent, like, long spikes most of the time, it tries to, like, do that, like, where it, like, pauses it every frame for a bit, which takes a lot of, like, CPU time as well. So, like, a bunch of, like, CPU time is, like, being spent just by the garbage collector just scanning the memory. So it's gonna scan a bit, resume application, scans another bit, pauses, like, lets the application run, scans another bit, lets the application run, scans another bit, and it just kind of keeps doing that. But if it doesn't have enough memory, it's gonna pause it and do a whole scan. With this one, the more modern, concurrent garbage collectors, they actually can scan they do most of their work while the application is still running. So the application's running, and then usually pauses it for much smaller amount to just do, whatever work requires the application to be paused. And that also helps a lot, for things to just perform like way better.
Yeah, there is to illustrate this difference, I was working with some like test program that was I think I mentioned this to you. It was reading data over USB, and it was written in C#. And since it's a test program, it's not written all that efficiently, and so it was allocating 40,000 a byte array of 40,000 bytes every 60 times a second, I should say.
Oh my!
And it was doing that, and the program like CPU usage was at like 0.1% while it was doing it.
Yeah.
And it was just like, wow.
It was very efficient.
Man, it was like throwing like flower petals at my feet and like putting luau's around my neck. You do that in mono, you get stabbed.
You die.
You die.
I remember like one of the things with garbage collectors, Java also tends to have really good garbage collectors. And we would be actually playing Minecraft, and I look, and it's like allocating several like dozens of megabytes per second, and it's just going whoop 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 whoop. It's just constantly like cleaning up, and you cannot really even tell. With Unity, you can be allocating, if you're allocating half a megabyte a second, constantly, you're gonna be dying. I had to spend time, just optimizing things to get it, under just a few dozen kilobytes per second. And that was really painful. It cost a lot of time, but it's just, how limited the garbage collector is. So I can't wait, like I can't wait until we like we're better runtime because like it's kind of gonna free us, from a lot of these things.